Okay, continuing with this, we have homework 13. We're now down to question 3. So here we get given a big vector puzzle, and we get given two vectors, A and B, and we'll see that they appear here and here. This shape is actually trapezium because this side is parallel to this side. We're now asked to work out a whole load of points, or asked to work out PR for the first one. So I'm going to use this as my diagram as I go, so I'm just going to put that there. So for 3, for part I, we're asked to work out PR. So we can now refer to our diagram here and work out that we're going to get from P to R by going from P to Q and then Q to R. So I'm actually going to write that down. P to Q plus Q to R. This is one bit that's good for very good mathematical notation, making sure you're writing down every single step you've got. This now follows a trail, so we go P to R by going P to Q, Q to R, no one can dispute that's the answer. Equals, P to Q is now 3A, plus Q to R is B. And that's that first part of the question done. No simplifying to do there. PS is the next bit. PS. So for here we're going to go P to, we know how to go from P to R. All we need to do is then go from R to S. So this is going to be P to R plus R to S. So we know our P to R, we did that for the first part of the question, and R to S is 4A, but it's actually going backwards along this vector, so it's minus 4A. So we've got our 3A plus B from the first part of the question, and then we need another minus 4A, because this is going backwards along this edge here. We can simplify this now. We're going to get B, we're going to get 3A minus 4A, so this is B minus A. Remembering all of these are vectors, so they do need to be underlined. For the next bit, to go from P to X, we can go any way we want, but actually we don't know this, or this, or this, or this. But we do have a fact here, which is P to X is K times P to R. And you'll notice down here, R is part of the things we're allowed to give in our answer, so it's going to involve K. So P to X equals, so for this one we're going to go from straight from P to X, but we're going to use the equation we get given here, which is Px is KPR. So this is KPR. We worked out PR in the first part of the question, it's this. So our answer is just K3A plus B. We can expand the brackets now to give us 3KA plus KB. So for this we just used the rule that we're given in the question, which is that this is just K times this. We can see from here, because the Px is shorter, K is going to be less than 1. For the last bit, we're asked to find Sx. So Sx we can get by going S to P plus P to X. We've got P to S, so S to P is just the other way around. So this is minus B minus A plus, and then we've got our 3KA plus KB from our PX from here. Tidying this up now, we get, so for the A's, we've got 3KA, and here we get a plus A, so this is 3K plus 1 A's. And here we get KB minus B, so we get K minus 1 B. And that's actually the end of the question now, because Sx is the final thing we're asked to find. There's a challenge question on the bottom of here. If anyone is interested in seeing the challenge question, I'm going to do that now. This is quite hard to spot, because we're actually not given any information at all about how to go from S to X. fact, we found Sx here. We're not given any information about k anywhere else in the question. We're given one bit of information, not told directly, that s to x is actually in the same line as s to q. So just like here, when we had p to x is lambda p to r, is kp to r, we're going to have another one here from sx and sq. So I'm going to write down, this is why this is a challenge question, completely challenge of my own free will, that Sx equals lambda Sq. Just simply because on our diagram these two are parallel to each other. This is a shorter multiple of this. What I can do now is I can write down, because I know Sx from here, and I can work out what Sq is. So Sx is this one we found here. So this is 3k plus 1a plus k minus 1b. This is equal to lambda. All I need to do now is work out Sq. So Sq from here, we're going to go this way. So this is 4a minus b. So this actually looks immediately like it's got worse. We've now got k and we've got this lambda. But because we need this equation to work for any a and b, not just particular ones, we know that we must have the same number of a's on this side as this side. So this gives me 3k plus 1 equals 4 lambda. And we must also, so these are the a's, we must also have the same for the b's. So we get k minus 1 on this side, and on here we've got minus lambda. I'm actually going to just simplify these so they're a little bit easier to solve. So we have 3k minus 4 lambda equals minus 1, and on here we've got k plus lambda equals 1. I'm going to multiply this equation here by 4, because this is going to make sure I have something that will cancel here. So I have 4k plus 4 lambda equals 4. I'm going to cross this one out to remind myself not to use that one. Now I'm going to add these two things together, because that will mean we get cancelling out of our lambdas, because k is the thing we're interested in. This gives me that 7k equals minus 1 plus 4 is 3, implying that k is 3 over 7. Okay, that's the end of the challenge question. Challenge question is quite tricky, so if you didn't spot this initial step here that we have to get from the question, it is quite difficult. But there we have the end of the challenge question.